Today we're talking about absolute value. This is 1-4 and the big ideas. When we are doing absolute, what is absolute value? Chris?
Any numbers distant from 0.
It's a distance from 0. Okay, so when I have something like this is an example of absolute value equations. And so what he means by distance from 0 is if this is a number line here, and here's 0, what does this statement actually mean here? Josh?
The actual value.
Okay, and so what possible values would make that a true statement? Caleb?
-5 or 5.
-5 or 5. So I could basically branch this off and say the absolute value, or once I branch it, you're saying that 5 fits in there and -5 fits in there. Okay, let me just do this. All right? So we could say that x could equal 5 or x could equal -5. Notice that every time I take the equation and I make the result, the right side set equal to the positive and the negative. Okay? So, if we're talking about this on the number line, what we're really saying is that our distance, if this is 0, and here's 5, and here's -5, it means this is 5 jumps, or 5 units, not negative, but 5 jumps to get to 0. And it's 5 jumps to get to 0 here too. Questions? So what would the solutions be for x in the first box? I mean, in the second box, the second problem. Caleb?
It could be, it could be negative minus -5.
Okay. What do you think, David? -5. Agree or disagree? John?
It would be, the negative would be in front of the line.
No, I can't really add it to that. I'm saying what could be my values here?
Oh.
That's my question. Chris?
There's no value that could possibly go to x.
Why?
Because all distances, they have to be positive.
Right. Distance has to be positive. So no matter what this is, it has to equal a positive value. Distance cannot be negative. Even when I'm measuring, if I took the tape measure, if I were measured this distance, it would measure 5 units. There is no tape measure that measures negative. There's no shoe store that sells negative sizes. I can't walk in and say, "May I have a -6, please?" They're going to laugh at me. So, we are, this is going to become your trick question. And every evil math teacher out there in the world, including myself, is going to try and trick you. And we are going to give you something very complex that will go inside there. It will be an equation and you'll be like, "Well, I kind of know it, but I haven't it doesn't matter how complicated it is. Because if it's set equal, absolute value set equal to a negative number, the answer is what? No solution. Everybody say no solution. There is no solution. So when we are doing this, it doesn't matter. I could put the quadratic formula inside that absolute value, and even though you don't know it, that's okay, because if it's equal to a negative number, it's still no solution. Is that clear? Okay, so now we jump to equations. Really what this is saying is something inside, a blob inside, the absolute value is equal to 5, this quantity. Okay, so I have to split it, just like I did in the equation up top in the left. And remember, what did we do? We set one of the absolute values equal to the positive and one equal to a negative because we have to account for the negative distance. Okay? Because we have to account for that negative distance on the number line. Now, I use every time, notice, inside the blue shade, it doesn't change. The only thing that changes is to the right of the absolute value, to the other end, the equal side. The expression that's on the other side of the absolute value, equal sign. So, when I substitute it in, I solve for n, and I get n equals 4. Is this a true statement? Does this work? Is 4 plus 1, what does it simplify to?
5.
So, the absolute value of 4 plus 1, and the way we do absolute value, we simplify inside. That's 5. Is that equal to 5?
Yes.
Yeah, it is 5. I don't take the absolute value till the end. Okay? Now we're going to try the next one. N plus 1 equals that negative 5. So, I'm going to subtract 1. I get n equals negative 6. And I substitute that into the original problem with the absolute value. And I get negative 6 plus 1. Does that equal positive 5? I'm going back to the original figure. So that's the absolute value of negative 5 equals 5. And I take my absolute value last. Does this work?
Yes.
All right, so there we go. We have two possible solutions. So with most absolute value, you're going to end up with two solutions. But you always want to check because it's not a given. Okay? All right, now you guys, now we put these in braces, not in parentheses, because we're putting them in the braces because it's not an ordered pair. When you put it in the parentheses, that assumes you're talking about an ordered pair on the coordinate plane. All right, so you guys take a minute and do this one. Remember, we're branching off into two equations. Go. Pause the recording and solve this absolute value equation. All right, so you should have broken this up into two equations and ended up with 18 and negative 12. And now you want to check your work and just make sure mentally that that's working when you substitute in. So negative 12 and negative 3 is negative 15. The absolute value of negative 15, is that equivalent to 15? And 18 minus 3 is 15. Is that equivalent? That works. So we're good. All right. We're going to start. We're running out of time. I've got like 9 minutes left. So I'm going to start going a little bit faster. So I might not finish these all the way through. I want to talk about different scenarios. So you have to think of your absolute value like it's a variable. So if this were a variable, what would we do? Nicole. Okay, so how would I begin? What would I start with? The whole thing is a variable. Just imagine that. Yeah. This is just think about what? Hello? I gotta go. I'll call you right back. Bye. Okay. So one more time. So we're going to pretend like this whole thing is a variable. So what would I do? We start with, we undo. We have to isolate our absolute value. Step 1, we isolate the absolute value. We cannot branch until our absolute value has been isolated. Here we get. Okay. Okay, now we can branch. Does that make sense? Okay, I'm going to go through this part really quick. So then we, add 3 to both sides, divide by 2. And we get 14. Yes.
Could you isolate for the absolute value part?
We
Like
always,
-2x
before we do anything, we get our absolute value alone.
No, but like once you get it, can you do -2x plus 3, and then you could also do.
At the point that the
2x.
absolute value is alone, that is the point where we branch them out, because we have to account for this entire chunk equaling a positive value and a negative value. This whole thing has to equal that positive value, and that whole thing has to equal this negative value. So that is the point that we branch it off. Okay, and so my solutions are -11 and 14. What do you think we would do here? What would I do here? David? To isolate my absolute value.
You divide both sides by 3.
That's right, because being next to means multiplication. So I am dividing both sides by 3, and I'm dividing both sides by 3, and this, Caleb, is the point at which I branch them out to. +6 and -6. Are there questions? Okay. Now here's an example of when we have a multi-step equation. So what would we start with first? Remember, your absolute value is like a variable. This is like 2x minus 7 equals 15. Nicole, what would I start with? Nope. When we are solving multi-step equations, we always start with what? So we undo our adding and subtracting. We actually do the reverse with inverse when it's in an equation. So I'm doing plus, I first do I peel it away like an onion, and I take the outer layer first. So first I get rid of the 7, add 7. It's always easier to undo your adding and subtracting before you're multiplying and dividing. And then, Jairus, divide both sides by 2. And now I am ready to split. We're setting x plus 1 equal to 11 and x plus 1 to negative. Once you set it equal to the positive and negative, you lose the absolute value sign. Questions? All right, I'm moving fast. Here we go. Now, I need to talk about... Okay, we have 2 different other scenarios that come up to be. When you have double absolute value, we're basically doing the same thing. Set the one side equal to the positive, and the one side, that same side also equal to the negative. But remember, it's the entire side. So I'm not just setting x, because it's everything in the absolute value. So I'm taking the negative value of what's in there. I would distribute that, right? X plus 5. Come on. Okay, I get x plus 5 equals negative x minus 11. Okay, I'm going to add x. I end up with 2x plus 5 equals negative 11. Subtract 5. And 2x equals negative 16. X equals negative 8. You with me? Now this next time, I'm doing my x plus 5 again, the same way. Only this time, I am setting it equal to the positive. X plus 11. When I distribute that, that's basically the same thing. Okay, let's do subtract 5. Subtract 5. I end up with x equals x plus 6. Subtract x. And what do I get? 0 equals 6. And in that situation, we call it no solution. When you're 2 values and you eliminate that variable, we call that no solution. So you only have one solution in this case. So you've got to check. Yes.
But let's say you cancel out the x's and let's say you're left with 6 equals 6, and that means there is a solution, right?
Yes. It means it could be anything. When you get two things that are equal, if you eliminate it, it means it's infinite. So in this case, let's check. This is -3 absolute value. Is that equal to +3 absolute value?
Yes.
They equivalent? Yes. All right. Next one. This is the one to look out for. Okay. Now, right away, we split. 2x plus 12 equals 4x. And 2x plus 12 equals -4x, right? I'm going to solve minus 2x. I get 12 equals 2x. Divide by 2. 6 is equal to my x. I'm going to do minus 2x minus 2x. I get 12 equals -6x divided by -6x, and x equals -2. All right, now we got to make sure they work. Does this work when x is 6? Does this work? 2 times 6 is 12, plus 12, it's 24, and 24, that's going to work. Now let's try the other one. I'm going to substitute in the -2 here. Okay. Doesn't that become -8 is equal to 2 times -2 plus 12. That's -4, +12 is 8. Is 8 equal to -8?
No.
And you can tell right here. Because if this whole thing is equal to -8, can absolute value equal a negative distance? No, they can't. So right there, just plugging in that -2 in for the x on the right side of the equation, it would have made it all negative. And then this is what we call an extraneous solution. It works for the equation, but it doesn't work for the idea of absolute value, because absolute value can't be negative. Augie, are you clear? Okay, questions? Yes, you should have written that example. You shouldn't just be looking. Yes?
If it doesn't work, then you don't put it in a bracket?
Right. The only solution would be 6. -2 is considered an extraneous solution. Yes? Yes. Yes, Caleb.
Could you graph it too if it's confusing?
Yeah, you can graph. I personally find graphing more difficult. Okay? I find it more difficult. Let me go right here. Here is the graphing method. Now, when graphing, it's got like 2 steps, really. The first step is we got to make this part, the first half of the equation, we have to set it equal to 0. So I just take that first half and I set it. What would the value of x be if I set that equal to 0? Huh? -2, right? So that's going to be my midpoint. -2 is my midpoint. Now I take the second part and I'm going to move 3 units in both directions from the midpoint. 1, 2, 3. That is one of my solutions. And 1, 2, 3. This is one of my solutions. So I have 2 solutions and they are -5 and 1. Now, did you understand what I just did? The first half, I found the midpoint by setting it equal to 0. I solved for x, and that became my midpoint. Then I use the second half of the equation to the right, and I move 3 units in both directions. This is what we call modeling with absolute value. Okay, let's try one more. Why don't you guys try and do this one? Or you can walk me through it. What would I do step 1? Where is my midpoint going to start? Ellie. -3, because I take the first half and I set it equal to 0. And this x would be a -3. Now, which way am I going to move to find my... I want to hear from somebody I haven't heard from today. Andy, what am I going to do next? Andranique.
Put the point in 1.
1, 4 units to the right, and -7, 4 units. Notice 1, 2, 3, 4. 1, 2, 3, 4. So my solutions are -7 and 1. And that is today's lesson.